Hi there, Kate. So before Daddy can give you the prize, you're going to have to promise Daddy to finish this because this is where you're going to be able to answer the questions on challenge number 4. Let Daddy start off with the first thing, okay, Kate? So a real detective in your classroom, it's going to be too long for you to be drawing unicorns. So we can't draw unicorns in the class. So what we're going to do, Kate, is we're going to represent the unicorns from now on by these little dots, okay? So we're going to call them dots. So each unicorn here will be represented by a dot right over here. So notice that you have 4 unicorns and you have 4 dots. So Daddy's just showing you that in the class, it's faster to represent it by dots instead of drawing unicorns, okay? So now here's really the challenge, okay? This is the 4th challenge. You are the detective at the end of the day, Kate. So in this challenge over here, Kate, what they're asking you to do is the following. Between the number 40 and 60, you need to tell the school which one of those numbers can you break up into equal groups, but with 3 or more different ways. Daddy will explain that again. So this is the number line right over here, Kate. So they are looking for numbers between 40 and 60. Between means we don't want 40 and we don't want 60. So that means that all these numbers, 41, 42, 43, all the way up to 57, 58, 59, these are all numbers that are suspect. And what the school is asking you to do, Kate, is they're asking you to say, if you pick a number like 45, can you break up the number 45 into equal groups? Okay, so they must be equal groups, but in 3 or more different ways. Can you do it in more than 3 or more different ways? So that's the task. So you need to go through and test each one of these numbers here and find out which number can you do it with and which number can you not do it with. In order to help you, Daddy's going to give you a clue. Okay, so here's Daddy's clue. Daddy's clue is that, let's say that you picked the number 45. Okay, can I break that number into equal groups of more than 3 different ways? And here's your detective clues. Okay, so let's say you took the number 45 here. Daddy's going to help you by saying, can you break 45 up into 2 different ways, 2 different groups that are the same size? Can you break 45 up into 3 different groups, again of the same size? That's why it's called equal groups. Can you break up the number 45 into 5 groups of equal size? So that is Daddy's help to you. Every single number from 41 to 59, you're going to try to break them up into groups of 2, then groups of 3, then groups of 5. If you can do that, then that number wins, okay? That number is the person who you're trying to catch. That's the suspect that you can break in equal groups. So let Daddy start off with the first number over here. Let Daddy try the number 46, okay? First, let's pick the number 46. If you look at this over here, the number 46 over here, Kate, notice that in the first way, there's one group. Okay, so that's one group times by how many people are in that group that will give us 46? Well, if you look at this carefully, if you count each one of these dots, 1, 2, 3, 4. If you count all of the little dots in here, which the school calls counters, there's exactly 46. So one group of 46 dots, 1 times 46, is equal to the number 46. So that is Daddy's first way to show exactly one group of equal size. Can I break up the number 46 up into 2 different groups of equal size? Well, here's a second way Daddy will show you. Okay. Notice over here, Daddy has 2 groups. This is my first group right over here. So notice my first group right over here. So that's my first group. That's group 1. And here's group number 2. That is Daddy's second group. Notice that the number of dots in each group are exactly the same, okay? So notice here, 1, 2, 3, 4. If you count all of these over here, there's 23 dots in this group. If you count all of these dots over here, there's exactly 23 dots in that group as well. So in this case here, Daddy has 2 groups. So that's 2 times by How many people are in each one of these groups? Well, we already said it. There's 23 people. If you do the math there, 2 times by 23 is 46. Or if you count every single one of these dots in the entire thing. So if you count all of those dots right over there, every single dot here, you're going to end up with 46 dots, right? So that's why 2 times by 23 is equal to 46. And that is Daddy's second way of being able to divide these guys up into equal groups. So that's way number one. That's way number two. Can we find a third way in order to split up the 46 dots into equal groups? No matter what number you choose, Kate, no matter what you choose, you cannot find a third way, no matter what you choose. That means the number 46, there's not 3 or more ways of breaking it up into different groups. So the number 46 cannot be part of the answer. So Daddy's going to cross that out, and Daddy's going to show you over here. The number 46 cannot be part of the answer because we cannot break it up into 3 or more different ways of equal groups. Let Daddy try the number 43. Okay, so let Daddy try the number 43. If you look at the number 43 over here, Bell is saying, can the number 43 be broken up into equal groups of 3 or more different ways? Well, the first way over here, notice that we only have one group. So that is our one group right over here. How many dots or how many counters, the school calls these counters, are inside of this one group? Well, if you count all of these dots over here, you have exactly 43 of them. So notice you have 43. So you have one group. It's the same size because there's only one group. 1 times by 43, that's how we mathematically say it. So the answer is 43. Well, that's one way to break up this group of 43 people, meaning that we put all 43 people inside this group. Can we find a second way to do this? Can we find a second way to break up the 43 dots into 2 equal groups or into 3 equal groups or into 4 equal groups? And no matter what you do, Kate, the answer is no. You cannot do this. So that means there's no way to find 3 or more different ways of breaking the number 43 up into different groups. Okay, so that means our number line here, we know from 41 to 59, 43 cannot be broken up into 3 or more ways of equal groups. Same thing as 46. Daddy just showed you those 2 examples. Daddy will do one more example over here. Baby Bell is saying, what if we try the number 45? That number is suspicious. Can we break up the number 45 into equal groups with 3 or more different ways? So here's what Daddy's going to say. Let's go to 45. We'll test it. Here's Daddy's first example in the number 45. This is Daddy's first example right over here. Well, how many groups? Let's count. This is 1. This is 2. This is 3. This is 4. This is 5. So we have 5 groups right over here. How many counters or how many of these dots are in this group? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 dots within inside that group. So we have 5 groups of 9 dots each. 5 times by 9 is 45. And 45 is exactly the number of dots. If you count every dot on this line, every dot on that line, every dot on this line, that line, and this line, and if you add all of those dots up, well, it's 45. This is our first way of essentially representing 45 as 5 equal groups of 9 dots each. Let's see if we can get it a second way. Okay, so let's look at this example right here, Kate. So Daddy's looking at this example and Daddy sees there's one big group right here. So that's our one group. How many people are inside of this group? If you count every dot inside of that group, every single one of these little dots, you're going to find that it's 45. I know it's hard to see from where you are, but Daddy's going to tell you that. So you have one group of 45 dots. That means 1 times by 45 is equal to 45. 1 times by anything is equal to 45. But the important thing here is that we represented this as equal groups. In this case, there's only one group, so the size is equal. So what we've shown so far is we have one way of representing the number 45 with 5 different groups of equal. So there are 9 people in each group. This is the second way. We have one group with 45 people. Well, there's only one group and it's the same size. Well, is there a third way? Well, let's look at this. We have one over here. Then we had a 1 by 45. That was our second way, Kate. And let's look at this third way. Can we represent all 45 dots a third different way? Well, when Daddy counts this over here, let's count the groups first. This is one group. This is 2 groups right over here. This is 3 groups right over here. So that is 3 groups. How many dots are in each group? Well, there's 1. Daddy's going to get another color. 1, 2, 3, 4, 5, 6, 7. If you count all of them in this group, there's 15 dots. So that's 15 dots. There's 3 groups that are the same size because each group is 15. So 3 times by 15 is equal to 45. There's 45 dots there. But the important thing in this lesson is that we found a third way. So this is the first way, the second way, the third way to represent the number 45 with equal groups. That means that the number 45, ding, 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 ding. So this must be the answer because we can split up the number 45 in equal groups, but we showed it in 3 different ways or more. There could be more ways. So that means that from our number line here, Kate, the number 45 must be part of the right answer. It must be part of the right answer because we were able to show that this number right here can be broken up into equal groups, but in 3 or more different ways. Now, this is how you answer this project. If you go through and do what Daddy just did, if you try to break up all of these things into groups of 3 or more different ways, the only ones that you can do that for is the number 42, the number 44, the number 45, which Daddy just showed you, the number 48, the number 50, the number 52, the number 54, and the number 56. Those are the winning numbers, meaning that we can break them up in 3 or more different ways of the same group. The last thing Daddy's going to say to you over here, Kate, is that Daddy's going to say that all the other ones, all the other numbers, when you go through and you try to break them up, you cannot break the number 41 up into equal groups of 3 or more ways. If you try that with the number 47, it won't work. If you try that with 49, it won't work. 51, it won't work. 53, 55, 57, 58, 59. Those numbers with an X do not work. Only the ones in green will work. And that's your winning numbers, Kate. So here's your winning numbers in the number in green that Daddy explained. Now they're going to ask you one more question, Kate. They're going to ask you pick a number and show the different groupings. Well, in Daddy's case, Daddy picked the number 45. Do you remember? So in this case over here, Daddy picked the number 45. So Daddy picked the number 45 in here. That was Daddy's choice. And Daddy showed that there was 3 different ways to represent the number 45 of equal groups, but 3 different ways. They will ask you to do that. That's the second question in this challenge. You need to draw that, okay? Now, the third question in this challenge is they're going to ask you this, Kate. How do we know, this is question 3, how do we know that we found all the different ways? And this is what you're going to tell them. You're going to tell them that the way that I know is because I went through and I tested every single number from 41 to 59. I tested it. And I found that these numbers over here, 41, 43, 47, 53, 59, they can only be represented by one different way where the groups are all the same. I also found the number 46, the number 49, the number 51, 55, 57, 58. Those numbers can only be represented as equal groups in 2 different ways. Okay, so that means that all of these numbers here, these numbers that Daddy crossed out, cannot be represented as equal groups in 3 or more different ways. Okay, so that's the only way that we can tell. And the winning numbers, the only numbers, remember Daddy tested number 45 are these numbers here that can be represented in 3 or more different ways of equal groups. And hooray, congratulations, you're all done.